I have a sociological background and I'm interested in how sociological theory and methods and practice can contribute to computational method, social computing and data science, and reciprocally how those new forms of understanding the social can enhance what we know from social science. And today I will try and demonstrate this through our research on influencer identification. So the motivation of this research is that I've been studying for 10 years now IT influencers, and the specific example of it, which is IT industry analyst. And we've been done a lot of research on it, and we've been left with a question: how do people become so influential? And we've decided to look at a career data and large amount of career data to understand how people build their credibility, their influence through changing jobs, to building a career in changing different companies and jobs. And of course, when you talk about influencer identification, a lot of literature on computational social network approach comes to mind, and this literature is essentially based on understanding influence from its consequences. So how do this literature understand influencer based on using Twitter data, how the position of influencers is in a certain network, and measuring how many tweets and retweets and connection they have based on their Twitter data. The problem here is that in this particular case, when you want to understand influencers based on how they influence a certain community, there are problems in how do you identify communities. The way information is diffused in each different community is different. Community has homophily and affect and a number of confounding factors, and if you want to study influence from how from its consequences, you can lose predictive power, because the influence has been happened already after you will be able to measure it. And identifying influencers based on their position in a network doesn't tell you how they get there. So how the pathway for them to get a central position in a network. So what we know from sociology of profession and sociology of expertise can help in this case. What you think when you think about the way you build a career as an academic? You build your career based on your ideal typical model of an academic career. In the same way, influencers as a profession try to imitate some prototypical career in their field. So what makes you an influencer is the peer pressure coming from your professional community. And of course, being able to identify the influences based on their career allows us to predict who is becoming the next influencer, and it's easier. We produce regularity in how we build our career, and we cannot say the same of communities that sanction how a message spread influence. Every community is different. It's hard to compute what a community is, and So sometimes, as we were discussing before about the psychological model, sometimes not psychological theory, the sociological theory can help identify where regularity is more likely to be found. And the question I have are, first of all, how can we measure careers? And then, is there a signature career typology among the most successful analysts or IT influencer? And the research has demonstrated, including LinkedIn research, has demonstrated that education doesn't have such an impact on career outcome in entrepreneurial careers. So if not education, what other early predictor can be identified to understand analyst career directionality? And then what type of career move most clearly differentiates successful analysts from other? It's the interprofessional move, the move, the inter-organizational move, so move across companies in the industry, or it is how quickly they change job within a single company. So another important element in sensitizing social data science is, for me, is the methodological component. Social scientists claim expertise by having spent a lot of time to study a particular practice. And therefore, when I built my team for the research, I was looking for people with text mining expertise, people with statistical expertise, but I also wanted them to share the same substantive knowledge on this particular field, the IT sector, and the study of careers. So it's very important to me to present my research team, and the member of the research team is Robin Williams at Edinburgh University, who had 20 years of experience in the study of IT expertise, and together with another colleague of ours in Edinburgh, Neil Pollock, is a co-author of the first academic book on this particular type of IT influencers, industry analysts. Beatrice Alex is the text mining expert in our team, and she already developed a software for parsing CVs of software engineer for recruitment companies. And Gilles Viry, who will be here next week to deliver a seminar on sequential analysis, is part of the team because of his statistical expertise, but because also he has experience in studying life course events, including work and occupational events. And Duncan Chappell is a member of our team, PhD student at Edinburgh University, but also an industry analyst himself. So we also have this continuous dialogue with the practice, which is fundamental to have good data quality, reliable data, and to return your ontological decision and check them. In fact, we had the privilege to have access to the larger data sets of industry analyst experience profiles in the world through our connections with the field. And this is a data set of 10,000 industry analyst profiles. And we start small. Another thing which is maybe due by my desire to understand what's going on with the data. And we've selected we accomplished a pilot, and I want to present some results, selecting, so the data sets we are working on also has a ranking of analysts, so there are the top 100 analysts, and so we created a sample based on these 100 top analysts and another random sample of analysts to test what was the possible difference, to answer our questions about is there a signature career in top analysts that make them different from the random sample. And we worked on creating an ontology to prepare the data based on company size, which is how how many times the company appears in our the data set, and company seniority. So the question to the data was, how long ago a person joined their last company? And in the average, the median number answer this question is 6 years ago. So the company that were joined in the last 6 years of a career are the new company, and then the companies that were joined earlier are old company, and the oldest companies are companies that nobody joined as their last company. So this is how our data is structured. So for every analyst, which we anonymize, we have their job title and seniority mark. We also went through normalizing and creating an hierarchy of job titles. We tell if the industry they work for is an analyst industry or not, and we also use different lists of industry analysts to make sure that we were considering only industry analysts and not procurement consultants or other type of professional. And then we have the size characteristics and the seniority characteristics. Findings. So we were talking about early predictors. By seeing the data, you immediately realize that there is a substantive difference between top analysts based on the length of their career compared with random analysts, their career in another profession, their career before getting the first analyst job, which is an interesting fact. Analyst jobs are in the average taken in the middle of or later in a career, and so the length of a career, of interprofessional career, and also the number of jobs. So you can see that the top analysts have longer career, interprofessional careers, and less jobs changed than random analysts in a sensibly shorter career. So people that have rigid interprofessional careers, so people that is likely to have stayed in the same company, and of course changing a job in the same company is harder than changing a job by changing company. So the interprofessional feature and the rigid nature of their interprofessional career can be one indicator of career outcome. And then we also start to do sequential analysis using Straminar, which is a library of R. And we classified companies in, we created a simpler alphabet of company. So these are the big three companies like Gartner, IDC, and Forrester. The yellow are the small houses, and we define when a person has a higher role in a small house based on our hierarchy of jobs. And then we have the dropout. The purple is when people exited the industry, and also the people history before joining the analyst industry. And then we have the personal portfolio type of move, which is a move that happens after having spent some time in the big three, and which defines when analysts go out and trade their expertise independently in the market by creating their own portfolio of clients. So one thing that we've noticed is by doing sequential analysis is the evolution of the industry, which is relevant when we are asking what is an indicator for a identifier of future analysts. I will compare the career started before 1990 with career started after 2000. So if you see career started before 1990, the purple color is dominant, which is the color which defines jobs in other industry, not analyst industry. And then you see that the green is almost dominant which is the big three, Gartner, IDC, and Forrester, when people take a analyst job. And if you compare this graph with this, which defines career started after 2000, you see that more and more people start their career in the industry, in the analyst industry as a first job. This is an increasing trend, so less dominance of the purple. And you also see that there are a lot of yellow lines. So a lot of people that join industry by taking a job in a smaller house, not necessarily in a big three companies. And this is really relevant because we need to be aware of weighting our results based on what are the most recent trends in the industry. And only the most recent trends in the industry will help us answer our question, what is the best indicator of who's going to be the next influencer? And then we need a little bit of Thomas here because our visualization are really ugly at the moment. But we want to be able to define a career vector, this is, you can see somehow a trend which defines one of the characteristics of careers that you have, career vector that you have in the most influential analysts. So people get into the green line, which is the big three, and they exit the big three and get to their personal portfolio type of move. So there are, and does that data visualization help us a lot because there is not only statistical relevance in our data, but there are also turning point of particular cases of careers that are only found with the most successful analysts. And we have to plot this as well as what is most relevant statistically. So another aspect in answering our question is to understand the role of large companies. So is people spending their career in large companies, and therefore the intra-professional moves are the most relevant indicator of career outcomes, or the unit of analysis which is most likely to give some relevant result to understand career vectors. And there are three hypotheses in the literature on the role of large companies in industries. One is that the large company is the first company people join when they work in a particular industry, because the large company has the economy of scale to be able to provide in-job training. And you train and you learn, and then you go out and trade your expertise independently. Surprisingly or not so surprisingly, based on our existing knowledge of the industry, the largest company when we ask what is the first company people join, the largest company is the second last in our data. So the role of large companies in this particular industry is not the one to be the one to provide training to early entrants. Another hypothesis is that when I went to Mountain View and speaking with LinkedIn about my research, and Lutzfinger, the director of analytics back then, said that these industry analysts are not influencers based on his understanding of influencers. They just exploit the reach of their company. And so based on this assumption, people would spend, would stay in a company, so our analysis of the turnover in a company, you see a lot of careers where people join and leave the big three, the green line, which means that this might not be the case for industry in the analyst industry. And there is another hypothesis, which is large companies are pool companies, where people join when there is no demand for their expertise on the market. So this looks like to confirm the hypothesis that large companies are pool companies that people join and leave depending on the demand on the market. So this pilot was an exploratory work that allows us to test initial hypothesis and produce a direction for future research when we will be able to analyze the full sample of the 10,000 analysts profile. So future work, we want to discuss a way to identify the typicality in analyst careers or typological multiplicity, assuming or having found in the pilot that there is not only one typical career, through application of clustering techniques, we want to identify which among the inter-organizational, the intra-organizational, or the interprofessional move correlate more strongly with career outcome. We have seen that the interprofessional move, so the length of interprofessional career, is a strong indicator of career outcome, but we've also seen that the industry is changing. So we can not only calculate the average, but we have to weight recent moves and the younger sections of, or the most recent section of careers. We have to weight them more than the rest. And we still believe that there is some interesting finding in interprofessional careers and interprofessional moves. So we were talking about rigidity of career before joining the analyst industry, and we want to apply measure of instability and fluctuation to understand to test this hypothesis about the correlation between interprofessional career and career outcome. And then we want to find which dimension, using our career vectors, which dimension, if it is the speed of changing job or the directionality, and what level of analysis offer the best pointer to career outcome. So there is a lot of work to be done and a lot of space for collaboration, not only from Thomas, who is certainly helping us to come up with a better visualization, but also to work with this very interesting data set. Thank you.